This video is to demonstrate to students how to do question 4B on the higher level engineering paper. So we're looking at thermal equilibrium diagrams, and in particular how to find the ratio of phases. So to draw a graph, label the main points, and then do a little calculation at the end. So the table shows the solidification temperatures for various alloys of metal A and B. The melting point A is 1083 degrees and the melting point B is 1453 degrees Celsius. These bits of information are important. If we look at our table down here, normally, or in a lot of cases, we have 0, 10, 20, 30 for the composition, the percentage of alloy B present. Okay. Instead of 0, we know that at 100% A, the solidification begins and end point is 1083. Okay. And then for 100% of B, 0% A, it's 1453 degrees for solidification starts and ends. Remember, with a pure alloy, or for a pure element, a pure metal, when it's not an alloy, solidification begins and ends at the same temperature. Okay. So, using the graph paper supplied, draw the thermal equilibrium diagram according to the data given. I don't have any graph paper on me at the minute, so I'm just going to use my answer book, but do use graph paper and make sure you practice using graph paper before your leaving cert. So on my horizontal here, I'm going to plot the composition. So on the extreme left, it's going to be 0% of metal B, so that's going to be 100% A, and then 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So that is percentage of B. That's my composition. On my vertical line here now, I'm going to put my temperatures. So I'll be starting at 0, and my max temperature is 1440. So just keep it easy. I'm just going to put each line is 100 degrees. So 100, 200, 300, 400, 5, 600, 7, 8, 900, 1000 degrees Celsius, 1100, 1200, 1300, 1400, and 1500. And just label it temperature, degrees Celsius, and just composition. Down at the bottom. So that's where my graph starts. So the next thing I have to do now is take the points here and put them into my graph. So at 0% B, so 100% A, 1083. Over here to my graph, there's some 1000, 1100, 1083 will be about there. So that's my first point. At 10% of B, it's 1160 and 1080. So I'm just going to use my ruler just to assist me with this. So 1160 and 1080. At 20%, 1220 and 1090. And 1090. At 30%, 1270 and 1110. 40%, 1320, 1140. 1320 and 1140. 50%, 1350, 1170. 1350 and 1170. At 60% B, it's 1380 1380 and 1220 at 70%, 1400 and 1270 at 80%, 1430 and 1330 at 90%, 1440 and 1380. 1380 is up here. And at 100%, 1453. So now I have all my points completed. Now I join it all up freehand. Like so. So that's the first part of the question. Drawing a graph given the data. Make sure that the graph joins on both ends. And make sure you put the composition on the horizontal and you put the temperature on the vertical. So the graph comes to one point on both ends. The next part was to label the main features. So this is part 2. So this is the liquid region. This is the solid region. This is the pasty region. This is my liquidus line. And this is my solidius line. So everything above the liquidus line is liquid, everything below the solidius line is solid, and everything in between the two is paste. Note that in this question, it only asks me to label the main features. In another question, it may ask me to describe. If it uses the word describe, then I need to give a little written explanation of each one. So finally then, part 3 of the question is to determine from the diagram the ratio of phases at 1250 degrees Celsius for an alloy of 50% B. So ratio of phases 1250 degrees Celsius, 50% B. So I'm just writing it down there just so I remember what I'm doing. So first thing, draw a vertical line from 50%. This is my alloy line. Like so. Come draw a horizontal line from 1250. Like so. It's my tie line. Where that tie line, where that horizontal line crosses the liquidus line, I'm given a point here, A. Where it meets the alloy line gives me B, and where it crosses the solidius line gives me point C. So the rule, ratio phases equals mass of the solid, which is AB, over the mass of the liquid, which is BC. So the next step I do, drop down points A and C. Drop them straight down the page, straight down the graph. So this will give you point A here, this will be B, this will be B, and this will be C over here. So A is going to be about 24. So A is going to be 50 minus 24. AB, I beg your pardon. AB is going to be 50 minus 24, which equals 26. BC is going to be C is about 68 minus 50, which is 18. So AB over BC is 26 over 18. And that is my ratio of phases. So just to recap on how you do that. Ratio of phases at 1250 degrees at 50% B. Draw a vertical line from B, a horizontal line, draw a vertical line at 50% B, and draw a horizontal line at 1250 degrees Celsius. Where that horizontal line puts the liquidus line gives you point A, where it cuts the vertical line from 50% gives you B, and C then is where it crosses the Saligius line. The ratio of phases is AB over BC. So we need to calculate the distance from B to A and B to C. So B to A is 50 minus 24, which equals 26. B to C is 68 minus 15, which is 18. So it's AB over BC, which equals 26 over 18. That's the end of the video. As I say, it's a question that most higher level students will be attempting on their Leaving Cert paper.